Okay, so we want to take a look at some real world applications of these equations that we have been solving, and we need to adjust our instructions here just a little bit. You will need to do this on your practice as well. From write a proportion or equation. So a proportion technically is an equation. So really what we mean by that is a linear equation. Um, so it doesn't necessarily have ratios in it. So we want to show our work and define our variables. So we kind of need to do three things, right? Typically, we define our variables first, then we write our equation or proportion, then we solve and show our work. So we're going to do those three parts for each of these problems. Okay, so if 2 pounds of fertilizer will cover 60 square feet of garden, how many square feet will 25 pounds of fertilizer cover? Okay, so here we're comparing two quantities and then we're continuing to compare two quantities further on down in the problem. So this is one of our proportions that you're going to want to be writing. Now, for our proportions, when you define your variables, right, so remember, we have three things that we're going to be doing. When you define your variables for a proportion, I'm okay if the way you do that is to just write your proportion in words. In fact, I think it's very useful. So we're looking at what are we comparing here, and we're comparing pounds of fertilizer to square feet of garden. So for our proportions, this is going to suffice for defining our variables, and it's also going to help us organize when we write our proportion. So we're now going to write our proportion, and this is where we're going to have a ratio equals another ratio, and we want to make sure that pounds of fertilizer is on the top, square feet of garden is always on the bottom, just like we wrote in number 1, comparing those two values. Okay, so it says 2 pounds of fertilizer to 60 square feet of garden. How many square feet will 25 pounds of fertilizer cover? So in the second portion, we know how much fertilizer we have, but we don't know how much square feet we have. So we're going to let that be our variable. So if you wanted to define it in a different way, we could say our variable or our unknown is pounds, not pounds, square feet. Having trouble writing this. So there we go, square feet of garden. That's what we want to know. We don't know that in the second part. Okay, so we're going to solve. We're going to solve by using cross multiplication here. Okay, so we're going to take 2 times x, that's 2x, equals 25 times 60, that's 1,500. Divide both sides by 2, so x equals 750. All right, but that is not the answer because that has no units on it. So with solving this problem, we actually need to answer the question, right? That's the solving part. So we can just put your answer with units is going to be acceptable here. So we can just, in this third step, we can just say this is 750 square feet of garden. So that when someone's looking at your problem, they can say, oh, hey, 750 square feet of garden. Otherwise, it's 750. Insert your favorite unit here. I'm going to go with elephants. Okay, so now we're going to get into some more of the linear equations that we're going to be setting up here. Find 2 consecutive odd integers whose sum is 168. So here we go. Again, we're going to need all the steps. Step 1, defining our variables. 2, writing an equation. And then 3, solving, which includes answering the question asked. So we have 2 integers here. We have a first integer and we have a second integer, okay? And if we think about a number line and we think about our odd integers, consecutive means next to each other. So those would be the 2 closest odd integers there. And then we want to think about how far apart they are. So they're 2 apart from each other on the number line, 2 units, okay? So I don't know what my first integer is. I don't know where I started. Here on the number line, I started at 1 and I went 2 spaces to get to my next odd integer, 3. But here I don't know where I started. And when I don't know something, that's where I put down a variable, x. Okay. Now, I also don't know my second integer, second odd integer. But what I do know is that it's 2 units away from my first one. So I'm going to say, well, this is my first one plus 2 units. Okay. So now we can continue on to solving our writing an equation. So this also says that I take these two integers and I take their sum, right? I add and I get 168. So I'm going to say my first integer x plus my second integer x plus 2 equals 168. Now that I have that, we can solve. 2x plus 2 equals 168. We can subtract 2 from both sides. 2x equals 166. Divide both sides by 2, and we get that x equals 83. But that doesn't answer my question because that only tells me about the first integer, right? X. Doesn't tell me anything about the second integer yet. So the way we're going to write our solution is simply in set notation with our two integers. So our first integer is 83, and our second integer is our first one plus 2, which would be 85. Just double check that we were looking for two odd integers. We got two odd integers. So if we got something that was even, a fraction, a decimal, we would have known that something went wrong and we should go back and check our work. Okay, next up. In an entire season, Kevin scored twice as many points as Larry and Gary. Oh, as Larry. And Gary scored 98 more points than Larry. Combined, they have a total score of 1,106 points. How many did each player score? So we need to start by defining our variables, which is essentially going to consist of listing our players and describing in variable form what's happening with their points. So we have Kevin, we have Larry, and we have Gary. Okay, the easiest way to do this is to write in words first under all of these guys, what's going on. So Kevin is twice Larry. Gary is 98 more than Larry. So now when I look at my list, Larry's the only one that doesn't have a description under it, which means Larry is kind of our baseline. He's the one that we're going to have to know to figure out everybody else. So when we go to define variables, Larry's going to be our x. And then all the other ones are going to be manipulated based off of Larry. So Kevin is twice Larry. Twice is what we use as a word for 2 times. So Kevin is 2 times x. And Gary is 98 more than Larry. So we use more than to indicate addition in this context. So we would say it's Larry plus 98 more points. Now we can set up our equation. So it says combined, right? So when we combine, we would add. They scored a total of 1,106 points. So I'm going to take Kevin, 2x, plus Larry, x, plus Gary, x plus 98, and set that equal to 1,106. And now we need to solve. So I'm going to start by simplifying, combining like terms. So that's 4x plus 98 equals 1,106. Then we can go ahead and take 1,106 minus 98, so subtracting 98 from both sides to get 4x equals 1,008. Divide both sides by 4, and we get x equals 252. We still need to answer our question. So we know Larry was x, so Larry scored 252 points. Kevin was Larry times 2, right? So that's 2 times 252, which is 504 points. And Gary scored 98 more than Larry. So we're going to take 252 and add 98 to it to get 350. Okay, to check your work, add all of them together, double check that you got 1,106. we'll say that's our final answer there. The only thing I'm going to add to this, which I forgot, is we're going to add units, points. So units are very important. Tells your reader what you're talking about, so that they don't have to make assumptions. Okay. A plumber charges $25 for a service call plus $50 per hour of service. Write an equation to represent this situation. So at this case, we're mostly looking for what the total service cost is, right? So we're going to be looking at total service and how to express that. So we're really going to have two variables here that we don't know about, right? We're going to have a y, which is typically the variable we're going to use for our total. So this is going to be our total bill. And our other unknown is that he makes $50 per hour, but we have no idea how many hours this guy is working. So this is going to be number of hours worked. So our total service in this case is going to look like y equals, right? Total service equals, and then what is included in this? So he gets $50 every hour he works. So if it's 1 hour, it's 1 times 50. If it's 2 hours, it's 2 times 50. But we don't know that hours. We just know we're multiplying by the number of hours. So we're going to have 50 times, well, we said x was our number of hours. So we're just going to let that variable sit there in place of our number of hours, and we'll insert a number later. Okay, and then it also says he charges $25 for a service call. So just to show up at your house, he's charging you 25 bucks even if he shows up and leaves. So we're going to tack that on at the end, plus 25, right? It's a one-time charge. It's not happening multiple times, so we're not going to multiply it by a variable. So now it asks, what's the total cost after 8 hours of work? Okay, so we have total cost is equal to 50 times the number of hours worked, which in this case is 8, plus that one time, hey, I'm going to show up at your house fee that the plumber charges. We're just going to go ahead and throw that into our calculator. We're going to find that y equals 425, which means our answer is going to cost $425. So again, make sure you have those units right there on your answer.